Hello everyone. Welcome to the solution of LeetCode problem 724 named Find Pivot Index. In this problem, we are given an integer array nums and we have to calculate the pivot index of the array. Here, the definition of the pivot index is the pivot index is the index where sum of all the numbers is strictly to the left of the index is equal to the sum of all the numbers is strictly to the right of the index. So here we have to return the leftmost pivot index. Here one condition is that if the index is on the left edge of the array, the left sum is 0 because there are no elements to the left. This is also applies to the right edge of the array. That means if the element in the right corner of the array, the right sum is 0 because it does not have any other right element. In the first example, the array contains 6 elements, which is 1, 7, 3, 6, 5, and 6. Here, for this element 6, the left sum will be 1 plus 7 plus 3, which is 11. The right sum will be 5 plus 6, which is 11. So here, 6 is the pivot number and the index number of 6 is 3 because index start from 0. So it is 0, 1, 2, 3. So here in this case, we have to return 3. In the second example, the array contains 3 elements, which is 1, 2, and 3, but there are no pivot index. In the third example, the pivot index is the first element because it has 3 elements, 2, 1, and minus 1. And for this element 2, the left sum will be 0 by default. The right sum will be 1 minus 1, which is 0. So both of them are equal. So here the pivot index is 0. I hope you understood the problem statement. Now the constraint are here. The array length can be in between 1 to 10 to the power 4. And each of the array element can be in between minus 1000 to positive 1000. I hope you understood the constraint as well as the problem statement. Now let's move on to the algorithm. In the algorithm, we have taken the first example. Here, the first example has 6 elements, which is 1, 7, 3, 6, 5, and 6. The index number is 0, 1, 2, 3, 4, and 5. Now, for this element 6, the summation in the left side will be 1 plus 7 plus 3, which is 11. And for this element 6, the summation in the right side is 5 plus 6, which is 11. So both of them are same. 11 is equal to 11. So in this case, we have to return 3, which is the pivot index or the pivot number. I hope you understood the problem now very well. Now let's move on to the detailed explanation of this problem. At first, we have to calculate the summation of the whole array, which is stored in the right sum, which is 28. Here, 28 is equal to 1 plus 7 plus 3 plus 6 plus 5 plus 6, which is 28. Now, the algorithm is pretty simple. At first, we will iterate from left to right. And suppose currently we are presented at this element. Now, for each of the element, we will check the summation of the left side values and we will check the summation of the all right side values. If they are equal, then we have to simply return the index number. So to calculate the value in the left side and in the right side, we have take two variables, which is right sum and left sum. Initially, right sum will contains the summation of whole array elements, which is 28, and the left sum is 0 by default. Now, in each iterations, we have to do something. Suppose currently we are presented at this first index. The array element is 1. Now we have to subtract 1 from the right sum. So here the right sum value will be 28 minus 1, which is 27. Now we have to check whether the right sum or the left sum is equal or not. So here 27 is not equal to left sum value, which is 0. So here we don't have to do anything. After that, we have to add the corresponding element to the left sum. So here the left sum value will become 1. So we have decreased 1 from the right sum and we have added 1 with the left sum. Now our current pointer is moved to the next element, which is this. Now our pointer is marking to the element 7. So now we have to discard 7 from the right sum. So here the right sum value will be 20, which is equal to all of the element sum in the right side. Here, which is 6 plus 6, 12 plus 5, 17 plus 3, which is 20. So for this element 7, the right sum value is 20. And we have to check whether the left sum or the right sum is equal or not. Here, the left sum is 1, which is this one, and right sum is 20, which is this. Both of them are not equal, so we don't have to do anything. Now we have to we have to add the corresponding element with the left sum. So here we have to add 7 with 1, which is 8 right now. Now our current pointer is pointing to this element 3. Now for this element 3, we have to subtract 3 from the element 20. If we subtract 3 from the element 20, the right sum will become 17, which is equal to 6 plus 6 plus 5. And we have to check whether the left sum and the right sum is equal to or not. Here, the left sum is 8, 1 plus 7, 8. And the right sum is 17, which is 6 plus 5 plus 6. But both of them are not equal, so we don't have to do anything here. Now, we have to add the corresponding element 3 with the right sum. So now, our right sum will be 8 plus 3, which is 11. Now, we shift our pointer to the next element. Now our pointer is pointing to this element 6. Now for this element 6, we have to subtract 6 from the right sum. So here, if we subtract 6 from the 17, the right sum will be 11. And we have to check here whether the left sum and the right sum is equal or not. So here, we see that the left sum value is 11 and the right sum value is 11. Here, the right sum is the summation of this 5 and 6, and left sum will be the summation is 1, 7, and 3. So both of them are equal. So here we can say that this index is the pivot index. So in this iteration, we have to return 3 and stop the algorithm. I hope you understood the algorithm. Anyways, I'm explaining it briefly. We are simply calculating two values, right sum and left sum. And for each of the element, we will check whether the value of the right sum is equal to the value of the left sum. If both of them are equal, we have to simply return the index number. Here, the index number is 3. For this element 6, the left sum and the right sum, both of them are equal, which is 11. So here in this problem, we have to return 3. I hope you understood the algorithm. Now let's move on to the code. In this problem, we are given a function named pivot index, which has a vector as the parameter. Now, at first, we have calculated the right sum, which is the summation of all of the element of the array. We are using the accumulate function. Now, we are using another variable, answer and the left sum, and we have initialized answer with the -1 in case we do not have any of the pivot index. And we initialize the left sum, which is equal to 0. After that, we are using a for loop from 0 to the end of the element. And in each iteration, we will first decrease the right sum value by a of I, and we will check whether the left sum is equal to right sum or not. If it is, then we have to simply return I. Otherwise, we have to increase the left sum by a of I. And if in all of the iteration, this loop does not return anything, that means this array does not has any of the pivot index. So here we have to return -1. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are iterating all of the element in the given input array, and the space complexity is big O of 1 because we are using constant extra memories to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.